So this is Mrs. Warden. I'm going to go over the classwork assignment for section 6.3, vectors and plane. This is the second half of that section. So the first one gives me an angle where it has b is equal to 5 times the cosine of 30 degrees I plus the sine of 30 degrees j. So if I were to write that in composite form, that would be the cosine of 30 degrees, sine of 30 degrees. And to find the magnitude of that, I would do cosine of 30 degrees squared plus the sine of 30 degrees squared. And I'm taking the square root of that. Well, you should remember from trig that cosine squared x for theta plus sine squared x for theta, that's always equal to 1. So if I have one set up like this, where it's written with the cosine and the sine, I know the magnitude of that part is just going to be 1. I'm going to take 5 times that. I'm going to do that. I'm going to have a magnitude of 5. To find my angle, well, they told me my angle. My angle is just going to be that 30 degrees. And that's all I had to do for 61 since it's written in that form. Now 64 is not written in that form, so I'm going to have to do a lot more work. So the first thing I'm going to do is I like to write -4 and -7. I like to write in positive form first. To find the magnitude, I'm going to take the square root of -4 squared plus -7 squared. And when I do all that work, I get the square root of 65. I'm just going to leave it as the square root of 65. There are no perfect squares of 65, so I cannot simplify. To find the angle, I'm going to think about this first. If I were to plot that point, that vector, I am going to realize that it's -4, -7, so that vector is in the third quadrant. So there's my vector. I'm doing my directional arrow, so I know that this vector is in the third quadrant. So I'm going to keep in mind that my angle needs to match that. My angle needs to be an angle in the third quadrant. So when I go and do the work, I'm going to do the inverse tangent of b, which is -7, over a, which is -4. And that's going to equal my theta. When I first put that in my calculator, I get a radian measure of 1.05, which changes to 60.3 degrees. So what has happened is I get this angle here, which is 60.3 degrees, which is in the first quadrant. I want the angle that goes in the third quadrant, so I want this angle here. So to get to that angle there, I'm just going to simply add 180 degrees. So my correct angle should be 240.3 degrees. So make sure when you're doing these problems that you check and make sure that it makes sense that your vector, where your vector lies, is where your angle also lies. So double check those quadrants. This number 67, it says find a component form of b given its magnitude and its angle. So all I'm going to do is I'm going to take the magnitude, which is 3, and I'm going to take the cosine, because that's my x value, the cosine of 0 degrees, sine of 0 degrees. I'm hoping you remember your unit circle. The cosine of 0 degrees is 1, the sine is 0. So my component form is just going to be simply 3, 0. And if you think about this, I don't know if you want to think about this, if you think about this, if I have a magnitude of 3 and an angle 0, well, here's 0 degrees, 1, 2, 3. So my vector should just be that vector right there, which is what I'm going to have with that 3, 0. Number 72, my magnitude is 3, and it's in the direction of 3, 4. So the first thing I have to do in order to do this problem is I have to find my angle. So I'm thinking of this as 3, 4, and I'm going to find the angle. 3, 4 is in the first quadrant, so I'm expecting an angle in the first quadrant. So I'm going to do the inverse tangent of 4 over 3. Remember that b over a, that's equal to theta. When I first put that in my calculator, I get the 0.927295, change that to degrees, and I get 53.13 degrees. So that angle, which is in the first quadrant, matches my vector, which is in the first quadrant, so that's great. Now to find this vector that has a magnitude of 3, I'm going to take 3 times the cosine of 53.13 degrees So when I'm doing this in a calculator, obviously 53 is not on my unit circle. And when I'm doing that in the calculator, I get 1.8, 2.4. And then when I check my answer in the back of the book, like, because I like to check my answer, they had a fraction. So if you happen to see that, what they did is when you had this angle here, where my tangent, there's my vector, and my tangent was 3, 4. So then they said, well, if this is a right triangle, then the missing side is 5. And so the cosine of this angle would be adjacent 3 over the hypotenuse, 5. And the sine of this angle would be the opposite over the hypotenuse. So they use 3/5 and 4/5 instead of actually doing the decimals. Either one's fine. I'm assuming most of you just going to try to calculate it just to cut the clock. Just wanted to let you know how they got that answer. In 73 and 76, it says find the determinant form of the sum of u and v. So I'm going to find u first, then I'm going to find v, and I'm going to add those two together to get my resultant vector. So for first one, u, I'm going to take 5, which is my magnitude, times the cosine of 60 degrees, sine of 60 degrees. Now 60 degrees is on my unit circle, so I'm going to use that fact that it's on my unit circle, and I'm going to say the cosine of 60 degrees is 1/2, and sine of 60 degrees is the square root of 3 over 2. So when I multiply the 5, I'm going to have 5 halves, and then 5 times the square root of 3 over 2. So this is u. Then to do v, I'm going to say v is equal to 5, and then I'm doing the cosine of 90 degrees, sine of 90 degrees. So v is going to equal 5, the cosine of 90 degrees is 0, the sine of 90 degrees is 1. So v is going to equal 0, 5. So now what I'm going to do to find the resultant vector, which I'm just going to call r is going to equal that 5 halves plus 0, and then 5 times the square root of 3 over 2 plus 5. Well, this first one is 5 halves, that's easy. And then this one, I'm going to maybe put this over denominator 2, so I'm going to end up with 10 plus 5 times the square root of 3 all over 2. And that is my resultant vector right there. And that's for number 76. I'm going to do, for u, I'm going to do 35 times the cosine of 25 degrees, sine of 25 degrees. Now this is going to be a decimal. I have no choice to sign on my circle. So u is equal to 31.72 and 14.79. And that's what I got after I distributed 35. Then when I do v is equal to 50 times the cosine of 120, sine of 120. So if I'm doing, since this one's already in decimal, I'm probably just going to do this one in decimal, but hopefully you remember that this was 1/2, and this is actually a negative 1/2. So when I do this, I'm going to get negative 25, and then I need it 50. Actually, it's 25 times the square. I just multiplied that. This one would convert to decimal. So when I convert, I'm going to do 31.72 plus that negative 25. My y part is 17. And when I do that, I get decimal. I get 6.72 and 58.09. I'm going to have you round everything to two decimals unless otherwise stated. It's just easier than 6. Okay, that's number 76. 77, use the law of cosines to find the angle theta between the vectors. So I'm going back to my formulas from 6-2. Just to remind you, we said, let's see, we say c squared is equal to a squared plus b squared minus 2a times b times cosine of c degrees. That was a lot of cosines. So I'm first going to draw the triangle, because that to me makes sense. So I'm going to go 1, 1, and there's that vector there. And then I'm going to go, this is 2, negative 2. So I'm going to go 2, negative 2, and I'm going to have this other vector there. So the first thing I did is I figured out the length of the, I'm making a triangle, this is what I'm trying to say. I'm making a triangle. I found the length of this line here. Well, if I'm going to draw that triangle over here. So this is the one that's 1, 1. So this is 1 and this is 1. So this, if I do right here, will end up being the square root of 2. So this side here is the square root of 2. This triangle here was 2, negative 2. So this side here is 2, this side here is negative 2. So when I do the Pythagorean theorem, we're going to do 2 squared plus negative 2 squared. So it's 4 plus 4, which is 8, which ends up being 2 times the square root of 2. So this is 2 times the square root of 2. So those are my two sides that I'm going to use. Let's say I call this A, and let's say I call this B. Then this side would be C, and look the triangle C. That's what I'm going to use that formula. So, that's I'm getting out of my way. So I am going to do C squared, which is, oh, I didn't find it. C squared is, find this side here. I'm going to find the distance between these 2 points. I can do that. So this point is 1, 1. This point is 2, negative 2. To find the distance between those 2 points is the difference of the x's. So 1 minus 2, which is 1, plus 1 minus negative 2, which is 3. So when I do that, I get the square root of 10. So this side C is going to be the square root of 10. Now I'm going to take all that information and substitute into this formula. So C squared will be the square root of 10 squared is equal to A squared, which will be the square root of 2 squared, plus B, which is 2 times the square root of 2 squared, minus 2A, whoops, AB times the cosine of C. So depending on how you want to do it, you're either throwing it into and solve, or you're going to actually do it. And when I actually did it, and I got my angle C, is equal to 90 degrees. So that's my final answer. This ends up being a rectangle. I do that actually. Okay. The next one, I have 3, 1, and 2, negative 1. So this is 3, 1. W is 2, negative 1. So what I have here is 1, 2, 3, 1. So that's this vector here. And then I have 2, negative 1. That's that vector there. So those are my two vectors. First, let's do it in opposite order this time. And let's say I want to find the length between these two first. So the distance between 3, 2. So 3 minus 2 here, I'll actually write it this time. 3 minus 2 plus 1 minus negative 1. So that's going to be 1 squared plus 2 squared, which ends up being the square root of 5. So that's the length of this line is the square root of 5. To find this first triangle, let's draw it off to the side. Red, drawing that off to the side. I have 3 and 1. So then this side here will be the square root of 3 squared plus 1 squared, which will be the square root of 10. And then doing this triangle, the 2, negative 1, 1, 2, 1. This is 2, negative 1. That's 2 squared plus negative 1 squared, ends up being the square root of 5. So this side ends up being the square root of 5. This side ends up being the square root of 10. You should recognize it as a 45, 45, 90 triangle, but if you didn't, then you would do a lot of cosines. But since these two sides are the same, it has to this one's twice as big. I guess I should say that. But let's say we didn't know that. So I'm looking for this angle here, which is obviously the square root of 5. So I'm going to say the square root of 5 squared is equal to the square root of 5 squared plus the square root of 10 squared minus 2 times the square root of 5 and the square root of 10 times the cosine of the part C and C degrees. And when I do that, I end up with 45 degrees. So that's how you do those two. That's just going back to law of cosine, so you can remember it. In number 79, it says you are given a graph and they want you to find a resulting vector. So you're taking this first vector, which has a magnitude of 400 and angle 25. So I'm going to say 400, and then I'm going to do cosine of 25 degrees, sine of 25 degrees. And that'll tell me exactly where that point is. That's what I'm doing, is I'm trying to find out exactly where that point is. Then the second part of that is I'm going to have 300 times the cosine of 70 degrees, sine of 70 degrees, and that is going to tell me where this point is. And then I'm going to find the resultant, which means I'm going to add those two together, and I will probably end up, it should make sense to me, you're going to end up with a point somewhere in between. And it's probably going to be a little further out because it's going in the same direction. So when I do this, I'm all calculator. I'm taking 400 times the cosine of 25 on my calculator, and then 362.52. I'm taking 400 times the sine of 25 degrees on my calculator. Remember to use that 3 symbol, and I'm getting 169.05. Then I'm doing the same thing now. I'm doing 300 times the cosine of 70, and I'm getting 102.61. 300 times the sine of 70, 281.91. Then what I'm going to do to find the resultant vector is I'm going to add this 362 to the 102, and when I do that, I get 465.13. Then I'm going to add the 169 to 281, and I'm going to get 415.96. Now you're just going to go up and grab these numbers and add them. You're not retyping all this stuff. So that gives me my component form. So what that means is if I wanted to graph this, I would go out 465 this way, and I would go up 450 this way. This would be 465-ish, and this would be 450-ish, and I would end up with this vector here. That's what that tells me. That's the component form. Now the question wants the magnitude, so the magnitude is like how long is this line? So to do that, I'm going to do, I'm going to call R result. Does that make sense to me? I'm going to do the square root of 465.13, squaring that, plus 450.96, squaring that. So I'm doing this all in one step, square root of all that in my calculator. And when I do that, I get 647.85. So that's how long that line is. That's my magnitude. If this were a word problem, it would have units attached to it, like miles per hour, kilometers per hour, something like that. Then it also wants the angle of the resultant vector. So to do that, I'm going to do inverse tangent. I'm going back up to this order here, right here. I'm going to do my B, which is 450.96, over my A, which is 465.13. I'm doing this in my calculator, and when I do this, I end up with, I didn't write radians first, sorry, I ended up with 44.11 degrees. So that should make sense because that 41 is between 25 and 70, and that's length of that line, 647, makes sense because they're both going in the same direction, so it will push it a little further out. That's 79. So now that leads us into our work problem 89. And so it's basically the same thing that you just did, except for there's, this one's asking a little slight different question. But this also introduces when we're going to have to use the bearing, the difference between a bearing and a trig angle or angle in standard position. So this one's nice because they gave you the picture, which should help you see some things here. What I noticed, first off, is I noticed that this both vectors down here are in the third quadrant. If they're in the third quadrant, remember, all students take calculus, or however you want to do that, I know that my cosine is going to be positive and my sine is going to be negative. So that's one thing I'm keeping in my head, is that I know that that has to happen. But I also have to find the correct angle for these. So let's do the 140 first. So here's 140 degrees. From here to here is 140 degrees. So I'm going to draw that off to the side, right? Plenty of room. So to get this angle, I did 140 degrees. Well, I want my trig angle, which is not 140 degrees, because in trig, 140 degrees is in the second quadrant, obviously not in the second quadrant. So then I think to myself, well, this is 90 degrees. So if I take away that 90 degrees, I'm left with 50 degrees. So this angle here would be 50 degrees. Because the 50 plus the 90 equals that 140. But I noticed that I went down. So if I were to draw this angle in standard position since I went down, I would make it negative 50 degrees. So I'm going to leave it as negative 50 degrees. If you want to add 360 and get 310, same thing with the exact same answer, just a little bit of different work. So that's the angle that I'm going to use for that 40 degrees. 140, sorry. Then for the 148, which is that's the speed of the airplane. The speed of the airplane is 148 degrees, so I'm going to draw the same shape over here, but this is now 148 degrees. And I need to find my trig angle, so I need to find my reference angle. And so I need to find this angle right here. So it should make sense to you that this here is 90 degrees. So I'm going to take away 90 degrees. And I'm going to end up with 58 degrees. So this chunk here is 58 degrees. But since I went in that clockwise position in trig, that's a negative angle, so I'm going to make it negative 58 degrees. Again, if you want to use 302, absolutely fine. Okay, so now what I'm saying, it tells me that the airplane is flying at 148 degrees with a speed of 860. Because of the wind, which I don't know, the ground speed is in direction R, 800 kilometers per hour, 140 degrees. So what that's saying is the pilot up there in the plane and all the passengers on the plane are going 860 kilometers at 148 degrees. But if I'm a person standing on the ground or the control tower, the plane isn't actually flying that fast. It's actually not actually going at that angle because the wind is pushing that plane a little bit, a lot, depending on the speed of the wind. So I know that it's going slightly off course because of the wind. And so this is what that little vector is right here. That is the wind, and that is what we are looking for. So what should make sense to you that if I'm up there, the plane plus the wind is going to equal what I see on the ground. That I'm hoping that makes sense. So the plane is at 860, and we said the angle that we're going to use for that is 148 degrees it's 148 degrees. So what we're going to do is we are going to 148 degrees. So we're using this negative 58 degrees. So negative 58 degrees. So this is a cosine of negative 58 degrees, sine of negative 58 degrees. So I'm going to take the plane plus the wind. Well, I don't know the wind. If the wind is going to be a vector, so I'm going to call it x and y for lack of anything else to call it. So that's going to be the speed of my wind. And then that's going to equal my ground speed. Well, they said on the ground it looks like the plane's only flying 800 kilometers per hour. And then the angle will be this one right here, so that's negative 50. So the cosine of negative 50, sine of negative 50. So again, all calculator. So I'm taking 860 times the cosine of the negative 58 degrees. And when I do that, I end up with 455.73. 860 times the sine of negative 58 degrees, and I end up with negative 729.32. And that makes sense that my cosine's positive, my sine's negative, because that's what I was expecting in that fourth quadrant. So then I'm going to add the wind, which I do not know, and I'm going to end up with 800 times the cosine of negative 50 degrees, which is 514.23, and then 800 times the sine of negative 50 degrees, which is negative 112. So what I'm doing when I'm solving this is I actually have like 455.73 plus whatever that exponent is equal to that 514.23. So to solve for that x, I'm going to take 514.23, subtract that 455. So when I do that, my x ends up being 58.5. Do the same thing for the y, so I'm going to take the 600, 612 to subtract the negative 729, and I get 116.49. So that's the component form of the wind, and what that means is, here's my wind, that's the component form right there. And I'm happy because it's in the first quadrant, and both my x and my y are positive. So it's making sense. So now what I'm going to do is it wants the speed. So to find the speed, that's the magnitude of the wind, that's equal to your speed. And to do that, I'm going to do the square root of 58.5 squared plus 116.49 squared. And when I do all that on the calculator, I get 130. Going up and checking my units, that's kilometers per hour. So that's my speed. To find the angle that I'm going at, I'm going to do the inverse tangent of my b, which is 116.49 over a of my y over my x. That's what I'm thinking about. And when I do this, I end up with an angle of 63.33 degrees. If you don't fall into that trap, that's not the correct answer because it wants the bearing. So let's go over here and draw a picture. So the angle I came up with, because I did trig, is this is my 0, and then I went up 63.3 degrees. The question is actually asking me, well, if this is my 0, how far did I go? So there's two ways I can do it. This is north, and this is east. So I can do north, east, and then I have to find that angle. I have to find this angle here. Well, these two angles together form 90 degrees. So I'm going to take 90 minus 63.3, and I'm going to end up with 26.7, which is 26.67 if I were rounding to two decimals. So this would be 26.67 degrees. And I can have 26.67 northeast, which is my bearing. That also happens to be the direction angle too. You just have 26.67 degrees as your direction angle. So either one of those will work. But remember, we didn't have a problem that we based off of 0 being north. You have to adjust your angles before you do it. Okay, then the last few are just work problems. All right, so I have, they give me these newtons, and the newtons are actually magnitude, so newtons is a different way of thinking of speed. It's the force that's pulling on that line. So it says find the direction and the magnitude of the resultant when the forces are 30 degrees. So this angle here, since it's straight here on the horizontal, that is going to be 0 degrees for my trig angle. So when I go to do this vector in blue, it's going to be 220 times the cosine of 0 degrees, sine of 0 degrees. And then I'm going to find the resultant, so I'm going to add that to this angle here, this vector here is what it covers. This vector here, which right now they're telling me this angle is 30 degrees. So I'm going to do 150 times the cosine of 30 degrees, sine of 30 degrees. So what helps me here is the cosine of 0 degrees is 1. The sine of 0 degrees is 0. So this first vector is going to be 220, 0. And then I'm going to add it to this one, which would be 75 times the square root of 3. 75, I believe. So when I add these, and I just threw it in decimals at that point, and I got 349.975. So it wants to find the direction of the magnitude. So now I'm going to have to find the magnitude of that, and I'm going to call R resultant. So we're going to have the square root of 349 squared plus 75 squared. And when I do all that, I end up with 357.85 newtons instead of like miles per hour. Newtons. And then to find the angle, I'm going to do the inverse tangent of 75 over 349.9. I'm going to do that. I did in degrees. Sorry, I just did 12.1 degrees. So it's 12.1 degrees. So that was pretty straightforward. And then it says write M, the magnitude of M as a resultant direction angle. They want you to write an equation for it. So I'm going to go back and sort of do the work that I did. I'm going to use the fact, so when I go to write M, I'm using the fact, first of all, that this point here, this angle here, this right here will never change. It's always going to be this, because I'm not changing it. I'm just changing like this angle here. That's all I'm changing. So to find the magnitude, it's always going to be that 220, 0. And then I'm going to add it to the 150, which is the magnitude, and then to do the cosine of whatever angle, I'm going to call x sine of x. I'm sure they told me what I would use that. I didn't use to say that. So my magnitude is always going to be 220 plus 150 times the cosine of x degrees. That's going to be squared. And then this is going to be 0 plus, so 0 plus 150 times the sine of x. And that's going to be squared. And then I'm going to find the square root of that. So if it were me, I would probably just throw it in my calculator like that and just go with it. But the book does not do that. And I probably, I can simplify this so much more. So what I'm going to do is I'm going to go ahead and simplify it. When I take 220 plus 150 times the cosine of x and I square that whole thing. I'm going to square that whole thing. So 220 squared will be 48,400. Then my middle term will be the 220 times 150, the two of those. So that's going to be 6, 0, 0, 0 is the cosine of x. And then I'm going to have 150 squared. I didn't write that. I should have. So plus, we're at 150 times cosine of x. Plus 150 times the sine of x. So the reason why I did that, let's see this here for a second. And then I'm thinking of this as 150 times so this is going to be, when I square that, it's going to be 22500 cosine squared x. And then this will be 22500 sine squared x. So cosine squared plus sine squared is equal to 1. So this will actually be, so I'm going to actually have this. And cosine squared x plus sine squared x. So then, 4,8,400, 6 cosine x. And then this one would be 22500 and 10. And then cosine squared plus sine squared is equal to 1. So I realized that everything is divisible by 100, so I factored out a 100, and I combined my terms, so I added this and this, and I ended up with 100 times 709 plus 660 times the cosine of x. Since I'm multiplying, I can take the square root of 100 times the square root of this, and so the square root of 100 is 10. Again, if you don't want to do all this work, which I'm assuming none of you really want to do, it's kind of fun to do, enjoy it, you could have stopped at this point here and put this in your calculator. But I'm going to put, because they asked me to write M, which I did, and that says read the graphing utility. So what they want you to do, what I would love you to do, is if you pick up your calculator, because you spent all the money on these things, let's actually use them. And I'm going to add a graphing page. And the reason why I'm going to add a graphing page is I'm going to type in that equation, and I'm going to have my calculator generate my answers. So here, again, this is what I'm typing in. If you didn't simplify it that far, then this is what you're typing in. Just be careful that you don't make a mistake. I'm probably not going to make a mistake typing this in, but we don't know. So I'm going to take 10, and then we multiply that by the square root of 709 plus 660 times the cosine. And then I'm going to put, since my chart, if I look at my chart is in degrees. See how all these angles are in degrees? So I'm going to want to leave them in degrees. So I have to tell my calculator, like, hey, even though you're in radians, you're in radian mode, I'm going to type degrees in on you. So I have to tell you that I'm doing that. So I'm going to hit X, and then I'm going to go over here and put the degree symbol in. So that's my formula that I have. I'm going to hit enter, and do not worry when you don't see anything, because I'm not going to see anything. And the reason why I'm not going to see anything is it's 660 times 709. So my very first point is going to be 709. Actually, it's going to be 1300, something like that. So I'm not going to see it. I don't care that I don't see it. I'm just going to go menu. I'm going to trace, do graph trace, and the first angle that I want is 0 degrees. And I'm going to hit 0, and down here I have 0, 370. So that's my first angle. Then I'm going to go and I'm going to keep on completing. So the next one I want is 30 degrees. So I get the 357.9, and that's a great check, because the reason why that's a great check is because we did that already. Did we not? We did. We got 349, and this gave me 357. Then I'm going to do, and I'm going to keep on going through the rest of the table, 60 degrees, 322, 90 degrees, and keep on filling in my table. Everyone good? Everyone's good. All right. The next thing I'm going to do is it wants the angle. So to find the angle, if I want to use my calculator, I can set up another equation. But remember, when I want to do my angle, I'm going to do the inverse tangent. And so here, when I did the inverse tangent, this ended up being, up here when I did the inverse tangent, this 75 was the sine of that angle. And then this was the 220 plus 100, oh, that's 150 times the angle. So what I'm going to do is I'm going to write that formula up here and say the inverse tangent. And I'm going to say 150 times the sine of whatever that angle is over 220 plus 150 times the cosine of that angle. Now, when I do this, that's going to be my angle. If I'm putting this in my calculator, I can put the degree symbol in when I type in the 0 degrees, 30 degrees, 60 degrees. I can do that, but when I type in the equation. But when I go to give my answer, it's going to give it to me in radians. And I can just take every decimal that I get and leave it. Or when I'm taking all this in the calculator, I can skip that step and take this whole thing and say, well, this is going to give it to me in radians, but I want it in degrees. So I'm going to take whatever that answer is and I'm going to multiply it by 180 over pi. And then when I do that, it'll give me my answer in degrees without having to go back and convert all those decimals. So I'm going to type that in. So I'm probably going to want to add another page because I do. I'm going to add a page. I'm going to add a graphing page. I'm going to type in that equation that I just had. So that's going to be the inverse tangent. Whoopsie, I actually want a parenthesis around that first. Inverse tangent. I like to use the division bar. And I'm going to do 150 sine of x degrees over 220 plus the cosine, 150 times the cosine, I always forget that, of x degrees. I'm going to look at that, make sure it's fine. And then, so I get my answer in, because right now it's in, this will be in radians, so now I want to multiply this to change it to degrees by 180 over pi. I'm going to hit enter. I have that. So now if I want to find 0, so let's do menu, analyze graph, no trace, sorry, trace, graph trace. I type in 0 degrees, I should get 0. That makes sense. Type in 30, get 12.1, so that'll be 12.1 degrees. No conversion necessary. 60, get 23, 90, get 34, and you keep on going. All right, hope that helps. Moving on to the next one. Again, if you're not comfortable using your calculator, then you're going to type in, you're going to set this up, type in 0 for the x's, type in 60 for the x's, type in 90, and just keep on getting your answers. Either way is fine. Okay, the next one is just a bunch of true and false, see if you understand what's going on. So the first one, if u and v have the same magnitude in the direction, then u is equal to v. Well, that is the actual definition of how vector u is equal to vector v, so that is true. If u is a unit vector, which means it has a magnitude of 1, in the direction of v, which means they have the same angle, then v is equal to its magnitude times u. That is true, because this will have the same direction. This tells me the magnitude of v, so that is true. If vector A is AI plus BJ is equal to 0, which means dot, then A is equal to the opposite of B. That is true. And then the last one, if U is equal to AI plus BJ is a unit vector, which means if it's a unit vector, that means if this is its in component form, if it's a unit vector, that means a squared plus b squared. When I take the square root of that, that's equal to 1. That's the definition of a unit vector, which means that this a squared plus b squared has to equal 1. So that is true. So all of those are true. Then 97 to 104, you're looking at the graph and you're seeing if it's true. So A goes up straight up 2 units. D is going down 2 units, but it wants the opposite of that. So instead of going down, it would go up 2 units. So this one is true. Let's highlight that. So So then the other one, 98C, which is there, is equal to S, which is that there. They're both going in the same direction. They both appear to have the same length. So that is also true. So A plus U, so A plus U, which would be this, is equal to C. So that is true. B, so going to the left 2 units, plus W, which is going up 2 units, so going up 2 units, is equal to S, the opposite of S. S is going, so this one's going this way, it would go the opposite direction, and that would be true. No, that would be false, actually. I thought. That would be false. The next one, A plus W. So A is going up 2 units, straight up, and W is going up 2 units. So A plus W would be going up 4 units. So up 4, just like that. Negative 2D. So D is going down 2, and then negative 2D would be down 2. So that would also be 4. So that is true. A plus D. So A is going up 2 units. A is going up 2 units, and D is going down 2 units. So if I go up 2 units and then down 2 units, I'm going to end up at 0. So that is true. I would have no change. U minus V. So U is going to the right 2. So going to the right 2. And then V is going to the left 2. Then with the opposite of that. So I'm going to go to the right 2 more. So this is actually 4 to the right. I want to think of it that way. B plus T. B is going to left 2. Left 2. And T is going to the left 2. So altogether, this is going to the left 4. And if I take negative 2 times that, that would be going to the right 8. Well, that's not right. So that is false. And then the last one, I have T, which is left 2. So T, which is left 2. Let's look at this way, left 2. And W, which is up 2, but I want the opposite of that, so it's down 2. So I'm going to the left 2 and down 2. So that's what I have for T minus W. B is going to the left 2. B. And then A is going up 2. A is going up 2, but I want the opposite of that, so I'm going to go down 2. And that's the exact same thing I had here, so that will be true. I kind of like to make this way better. And that is the crossword. I hope that helps, and I will see you next time.